So let's just see how we can convert one binary tree into one binary search tree. So this is one binary tree because here each node has maximum of 2 child. Now if we wanted to convert this to one binary search tree, so we're gonna keep the structure same. We have to shift these values so that we have the property of the binary search tree. So as we know, in a binary search tree, the left child has smaller value than the root and the right child has larger value than the root. So first of all, we're gonna traverse this binary tree. So we're gonna perform the in-order traversal. So we're gonna start the traversal. So whenever we reach bottom of one node, we're gonna include this in our in-order traversal. So first of all, we have 4, then we have 2, then we have 5, then we have 1, and then we have 3. So as we know, whenever we perform the in-order traversal in a binary search tree, all the values are sorted. Because here the values are not sorted, that means this is not a binary search tree. Now to convert this to the binary search tree, we need to sort our array. So we're gonna sort our array. So if we sort this array, so we're gonna have 1, 2, 3, 4 and 5. So now all you have to do is we have to put these sorted values back into our tree structure. So because we wanted to keep the structure of the tree, so the structure will be same. We just need to put these values into this tree so that this property of the binary search tree is maintained, where the left child will be smaller than the root and the right child will be larger than the root. So that means here we're gonna perform the in-order traversal and we're gonna insert all of these values into this tree structure. So first of all, we're gonna put this value 1, then we're gonna put this value 2, then we're gonna put this value 3, then we're gonna put this value 4, and then lastly we're gonna put this value 5. So now you can see our binary tree is converted into binary search tree, and here you can notice the left child is smaller than the root and the right child is larger than the root, and this applies to all the nodes. So here also you can see the left child is smaller than the root and the right child is larger than the root. So that means we can say that this is one binary search tree. So this way we have to follow this algorithm. First of all, we have to perform the in-order traversal, then we have to sort the array, and after that we're gonna just insert all of these values into our tree structure, and the end result will be the binary search tree. So here we have the code. So here first of all we have defined the node structure, then this is to allocate memory for a new node, and here is the function store in order. So this function used to traverse our binary tree and put all of these values into one array. So here first of all the function takes the root node of this tree, then it takes the array, so this array where we wanted to insert all of these traversal data, and this is the index. So first of all we're gonna check if the root is null. So if the tree is empty, then we're gonna return. So this is the base case. Now here we are performing the in-order traversal. So first of all we're gonna recursively call with the left child. So that means we are traversing the left subtree, and then we're gonna extract the data of the root node and we're gonna put that into our array. So that means one by one we're gonna store the data into one array, and then we're gonna traverse the right child. So here we are basically first of all we are traversing the left child, then we are extracting the root data, and then we are traversing the right child. So this way we're gonna recursively traverse this binary tree and we're gonna extract all of that in-order data into this array. And the next step is to sort our array. So here you can see binary tree to BST. So first of all allocated memory for the array, then we have called this store in order function. So this is to traverse the tree and put all of that data into our array. Now next we have to perform the sort. So here we are performing the sorting using the comparator. So this is our comparator function to perform the sorting in ascending order. Now after we have done with the sorting, then we have to insert all of these values So that means we are calling this array to BST function. So the function basically takes the array and it will insert all of these array data into our tree structure. So this is the function array to BST. So this function will take the root and we're gonna override all of the data. So here is our array. So this array data will be inserted into this tree. So first of all, we're gonna check if the root is null. That means if the tree is empty, then we're gonna return. Otherwise, we're gonna call this array to BST recursively. So first of all, we're gonna recursively traverse the left subtree. That means this left subtree. And then we're gonna override the root data with the array value. So that means one by one, we're gonna take the array data and we're gonna insert this into our tree structure. So first of all, we have traversed the left subtree. Then we're gonna insert our data. After that, we're gonna recursively traverse the right subtree. And this way, we're gonna take values one after another and we're gonna put that into our tree. So all the tree data will be overridden with these array values. And the end result will be this binary search tree. So inside the main method, we have created this simple binary tree with the values 1, 2, 3, 4, 5. So that means we have created this simple binary tree. So now if we perform this Inorder traversal, so currently you can see all the data are not sorted. That is because that is not a binary search tree. So to convert this to the binary search tree, we're gonna call the function binary tree to BST. And here we're gonna pass the root node. So after we have converted to the BST, if we print the Inorder traversal of our tree, now the data should be sorted. So you can see this was the original binary tree. Now after the conversion, you can see all the elements are sorted. That means our tree is successfully converted to this binary search tree. So hope you understand about the conversion of the binary search tree. See you in the next one. Take care.